We're asked to find the domain of h of x, which is equal to the square root of 4 minus x all over x plus 1, and then we have x squared plus 1. Alright, so for domain, what are the restrictions? What are the two things that, when we're asked to find the domain, what are the two things that should pop in our head automatically? What causes a restriction in the domain? What are the two things? We said it earlier, say it again. I want to say it again and again and again and again and again. Zero in the denominator and what? And square roots. And here we have a denominator and a square root. So let's deal with the square root. The square root, what's the problem with the square root? I can't take a square root of a negative number, so that means that 4 minus x has to be greater than or equal to 0, and that's a fancy way of saying not a negative number. Right? So I'm going to solve this algebraically. Actually, your textbook wants you to do it like this. And then determine what the inequality symbol should be at the end. Because it gets confusing when you have quadratics or absolute values and stuff like that. So I'm going to subtract 4 from both sides, and I get negative x is equal to negative 4. But we know that so if x equals negative 4, or positive 4 I mean, now what do I want that to be? Does that mean x could be greater than 4, less than 4? How does that work? It has to be less than. Now in this case, if I would have left this inequality symbol, when I multiply both sides by a negative value, negative 1 to reverse the sign, I would have gotten x is less than negative 4. But just think about it. If I plug in a 5, I have a negative value under the square root symbol. Alright, so it has to be less than 4. Can it equal 4? Yeah, because the square root of 0 is 0. Right? So that's one thing. What's the other thing that we got to think about for domains? Zero in the denominator. Now, if you look at this, x plus 1 cannot equal 0, so I got x cannot equal negative 1, right? If I do this over here, I've got x squared cannot equal negative 1. Well, that's true because anything I square will never equal a negative number, right? It'll equal an irrational number, or not irrational, imaginary number. In other words, if I were to take the square root of both sides, I can't. Not with real numbers. And so my domain, I'm only focusing on real numbers. This is a special case. We know that x cannot equal, what is the square root of negative 1? We just covered that. I. And so we're going to ignore that for now. Let's graph that. This is important though. It'll come up in the graph when we go to graph it, and I'll explain that to you if you really care. So let's graph it and see what it looks like. So I'm going to plug it in my calculator. And I'm going to plug in the square root of 4 minus x divided by, and I got to do double parentheses because I want to put all of this in parentheses because that's the only way my calculator will understand it. So I'm going to say x plus 1. If you don't put it that way, it'll give you the wrong graph. Times the quantity x squared plus 1. Well, it said x had to be less than 4, so how does that come into play? Let's trace it and see. As I approach 4 in the x direction, what happens to my y values? They go down. But notice that when I go to 4, it's undefined. There is no y value. We can see this too in the table. Once you get to 4, right, the numerator will be the square root of 4 minus 4, which would be 0. The square root of 0 is 0. And so at that point, you can no longer take a square root. So as we look at all the values greater than 4, there's an error because mathematically we can't get a real number answer. Okay. So how do I write that? Well, first let's graph it real quick. Well, I got to look at the graph again. I forgot what it looked like. So I've got something that looks like this. This is my XY plane. We've got a vertical asymptote at x cannot equal -1. And it looks like my graph kind of looks like this. Now the only other thing I got to think about is that x equals 4. It looks like my graph comes in and gets really, really close and just stops. And that's the end of the graph. So now how do I write that in interval notation? Well, my domain is, what's the first part I put in here? Help me fill in the parentheses. What goes here? Negative infinity to -1. Am I including the -1? No, I can't. What about here? -1. And then 4, right? Now, why did Mr. Adams put the bracket here with 4? Because we're including it, right? We're including it. So let's make that very prominent that that's a bracket. Okay? Any questions on that one?